Welcome everyone to Lesson 8, Simplify Square Roots and Imaginary Numbers. I'm hoping this lesson will be on the nicer side. It's only one page, so let's dive right into it. So we're going to not only be simplifying square roots, but simplifying negative square roots as well. So the first concept we're going to talk about is simplifying radicals, or what I like to call square roots. So the first thing we need to do is just talk about the anatomy of a radical. So here we have the square root of x. Now, what we call the square root, its more formal name is the radical. But again, you will hear me saying square root. And we'll spend more time with radicals later in the school year. And then finally, we're going to have a number underneath, and the formal term for this is radicand. This will probably be the only time you hear me say radicand, just because I like to call it the number inside. Again, you only need to know these mathematical terms if they come up, say, when you are taking SAT, ACT, or the state test, you need to know what radical and radicand mean. So let's go through the steps how to simplify non-perfect square roots, because that's what we're doing. We're simplifying non-perfect square roots, because perfect square roots are easy. You take the square root of them. But non-perfect squares, we're not going to be messing around with decimals. We can break them down. So, to do this, the first thing we do is to break down into prime numbers using a prime number tree. And to give you just a little diagram of what this is going to look like, we start with a number, and then we break it down into two numbers that, when multiplied, give us the top number. And so on. We just keep breaking it down until we can't anymore. After we do that, we're going to find pairs of the same number. And then step 3 is what I like to call keep one, chuck one. So we're going to be keeping one of the items from a pair and chucking the other one. Now, non-paired numbers, because you may have numbers that don't have a pair. Those guys stay inside the square root. Now that we've broken these numbers apart, we've kept some, we've chucked some have stayed inside, we may need to simplify by using multiplication. All right, so let's get into our two simplifying radicals. So we have the square root of 40. So we're going to break 40 down using a prime number tree. So I know that 4 and 10 multiply to give us 40. I check, is 4 prime? No. Is 10 prime? No. So we keep breaking it down. 4 can be broken down into 2 and 2. Is 2 prime? Yes. Is 2? Yep. So we circle them to know we can't go further. Now we break down 10. 10 can be broken down into 2 and 5. We already know 2 is a prime number. And then is 5 a prime number? Yes, it is. So we circle it as well. As you can see, everything is circled. We can't branch off anymore, so we stop. Now, what we're going to do with these numbers is we are going to list them underneath the square root in numerical order. So we have 2 times 2 times 2, because I have 3 2's, and then a 5. Now we're on to step 3. Or actually, no, step 2. We haven't even found our pairs. So identify your pairs. So we have one pair of 2's, and then we don't have a pair for this last 2, and we don't have a pair for the 5. So those will stay inside because they do not have a pair. Now, we look at the pair that we do have, 2 and 2. Keep 1 and it comes out in front, and chuck the second one. It goes away. So the keep 1 comes outside the square root. And since it's the only thing being brought outside, it's the only thing there. And then inside, well, it's the numbers without pairs. And we simplify by using multiplication. 2 times 5 is 10. There you have it. That is fully simplified. All right, let's do one more. Square root of 108. So we come over here. We're going to break down 108. Now, when in doubt, if you don't know where to start, this is an even number. What do we know about even numbers? They can be divided by 2. So when in doubt, try 2. We can circle this guy. Now we can break down 54. So 54 can be broken down, again, when in doubt. Take out a 2, and we're left with 27. We circle 2. 27 can now be broken down to 3 and 9. 3 is a prime, so we circle it. And 9 can be broken down to 3 and 3. And we circle both of them. So now we come back up here. We list out all our numbers. 2 times 2 times 3 times 3 times 3. We identify our pairs. We have a pair of 2s and we have a pair of 3s. Now, keep 1, chuck 1. Keep 1, chuck 1. So coming to the outside is 1, 2, and 1, 3. And we multiply them. So 6 is on the outside, and remaining inside is 3. So there you have it. We've simplified the square root of 4 and the square root of 108. All right, final concept. Imaginary number. So the number square root of -1 is called the imaginary number I. Replacing the square root of -1 with I allows us to write solutions nicer. We simplify the square roots the same way, so we're going to do the prime factor tree, but we remove the negative and replace it with the I on the outside. So I advise you to do this step first. So here we have the square root of -80. What I'm going to do is I'm going to bring this negative, bring it to the outside, and now what we're working with is I square root 80. So I would do that first so you don't lose track of that I. Now it's time to simplify the square root of 80 by doing our prime factor tree. So we have 8 and 10. 8 can be broken up as 2 and 4. And 4 is broken up as 2 and 2. 10 is broken up as 2 and 5. So now I'm going to go back through and circle all my primes. Now we rewrite them. I is still on the outside. So we have 2, 2, 2, 2, 5. We have one pair of 2s. We have a second pair of 2s. Keep 1, chuck 1. Keep 1, chuck 1. So as you can see, the only thing staying inside is a 5. And then coming to the outside with I are 2 2s, which is 4. So the square root of -80 simplifies to 4i square root 5. One more example and we'll be done with this lesson. Again, automatically start with bringing that negative to the outside. So the square root of -175 now becomes I square root 175. So now time to break down 175. So 175 broken down 5 and 35. And then 35 can be broken down into 5 and 7. 5 is prime, so is 7. I is still on the outside. Square root of 5 times 5 times 7. We only have a pair of 5s, so we keep one 5, chuck the other 5. So 5 comes to the outside with I, and 7 is left inside the square root. And that is simplifying positive and negative square roots.